need to return images, audio, or files from your AI tools without wrestling with base 64 encoding or MIME types. You'll see how FastMCP's media helper classes simplify returning rich content, whether it's a single chart image or a list of files, while handling all the conversion and formatting automatically. The pattern uses image, audio, and file types to cleanly expose media to your AI with zero manual encoding.
From FastMCP utilities types import image, audio, file. At MCP, tool. Def get chart, image. Generate a chart image. Return image path equals chart, PNG. At MCP, tool. Def get multiple charts, list image. Return multiple charts. Return image path equals chart 1, PNG. Image path equals chart 2, PNG.
This demonstrates the tool abstraction pattern for exposing Python functions as AI-callable capabilities. The decorator-based approach transforms ordinary functions into self-describing tools that AI models can discover and invoke, complete with type safety and automatic schema generation. What makes this distinctive is how it bridges the gap between human-readable Python and machine-readable tool definitions without requiring manual API boilerplate. The pattern works by leveraging Python's type system and decorator metadata to create a declarative interface. When you decorate a function with @MCP tool, the framework introspects its signature, extracts type information, and generates a complete tool specification, including parameter validation and return type handling. This separation of concerns means your implementation stays clean while the framework manages all the RPC complexity, from serialization to transport. This approach matters because it solves the integration problem between AI systems and backend logic. Instead of writing custom API layers or maintaining separate documentation, you define tools as native Python functions with full type safety. The pattern is particularly valuable for AI workflows where you need to expose capabilities dynamically, with the trade-off being that you must adhere to the framework's type constraints. It's ideal for scenarios where you want AI models to interact with your codebase directly, without intermediate translation layers. Let's break it down line by line.
From FastMCP utilities types import image, audio, file.
This imports image, audio, and file type classes from FastMCP's utilities, enabling strongly typed tool outputs. These types standardize how AI models receive binary data, ensuring consistent handling of images, audio, and files across tools.
At MCP, tool. Def get chart, image. Generate a chart image.
This decorator exposes getChart as an AI-callable tool in FastMCP. The return type hint, image, and docstring define the tool's schema, enabling automatic API generation and validation.
Return image path equals chart, PNG.
This returns an image object with the file path to the generated chart. The type system ensures FastMCP knows this tool outputs an image, enabling proper handling by AI models and downstream tools. This pattern maintains clean separation between generation logic and output specification.
At MCP, tool. Def get multiple charts, list image. Return multiple charts.
This defines an AI-callable tool that returns multiple images as a typed list. The @MCP tool decorator exposes it to AI models, while the return type, list image, enforces structured output, ensuring the AI receives predictable, strongly typed data.
Return image path equals chart 1, PNG. Image path equals chart 2, PNG.
This returns a list of image objects, demonstrating how to handle multiple outputs from a single tool. The pattern matches the function's return type hint, list image, ensuring type safety and clear documentation for AI callers. FastMCP content conversion pattern. The image, audio, and file helpers automatically bridge Python objects to MCP content blocks when returned directly or in lists, handling MIME types and base64 encoding behind the scenes. Nested containers like dictionaries require manual conversion via to content methods to trigger the same transformation. This pattern eliminates boilerplate while maintaining explicit control when needed.
The helper that disappears into the protocol becomes the protocol itself.